Hey, so boys and girls, we will start our lesson today. Hi everyone, I'm Dr. Lo. Okay, we are learning at S level, okay, year 12 syllabus lah, okay. In year 12, we will total have 11 chapters. So right now, I go through the mind map and let you know that what we will learn in our A level, okay, for our year 12 lah. So in chapter 1, we will learn about physical quantity and units. So at here, today we'll learn physical quantity, how we do some estimations, SI unit, power of 10, okay, learn about errors and uncertainty, okay, what kinds of error we will have, okay, cause the error, then precisions, accuracy, then we'll learn about, this one is the new thing, how we find the uncertainty, okay. Then after that, in the physical quantity chapter 1, one more subtopic, we'll learn about scalar and vector quantity, okay, scalar and vector. So we will draw the vector diagram to find some resultant vector or resultant, the force, resultant, the velocity, and so on. Okay, then we will learn about resolution of forces, yes, or we learn about resolution of velocity lah. That is resolution of the vector. Okay, this is chapter 1. Basically, chapter 1 is the most easiest chapter lah in our A level. Okay, then chapter 2, we will learn about kinematic. Okay, this one is to learn about the motion. Okay, so we will learn about motion graph. Okay, then we will learn about the kinematic equation. So we need to know how to do derivations, how we get these four equations in A level. There is a lot of derive. Okay, then we will learn about the difficult and challenging part. Actually, is this projectile motion. Okay, projectile motion. So no longer one dimension, but we need to throw and then we need to consider two directions. So this one is in chapter 2. Okay, chapter 2 is learn about the motion, but we didn't learn about how the motion is work. That is on chapter 3. So in chapter 3 is called dynamic. This one is learn about dynamic, learn about motion, and then the motion is y, so it will involve with force. F equals to ma will be mentioned in this chapter 3. Okay, dynamic. So we'll learn about Newton's law. Okay, seems like similar with what we learned in our year 10 and year 11, the topic, but actually it's go deeper lah. Okay, the knowledge have to go in deeper. Then for this chapter, we will learn about the linear momentum, and then the momentum that we learn in year 10 or we learn in form 4 is actually in one dimension. Okay, one dimension only, but here in A level we will learn about two dimensions, so we need to resolve it into the same direction, then we only continue do the calculation lah. Okay, so this one is about chapter 3. So it's learning about the motion with y, learning relate motion with the force. Okay, this is chapter 3. Then chapter 4 is about force, density, and pressure. So at the force, at here we learn about turning effect, moments. But the moments that we learn is no longer uh, in horizontal. Okay, we will have certain angles. So again, you need to resolve it. Then only in the correct directions, then you only can continue to solve it lah. Okay, previously what we learned about moment is the force and the distance must be perpendicular. So most of the case in our year 10, we actually the value for the force and the distance they provide most of the time is actually already 90 degree for you. Okay, so in A level they will give you certain angle, so we need to resolve it until the direction is correct direction, then we continue to do calculation lah. So we learn about torque. Then after that, we learn about equilibrium of forces. We learn about density and pressure. So although density is still using the same formula, but inside here there is something we need to learn about more. When they mix the liquid, okay, then what is their density for the mixture and so on lah. Okay, so pressure. Then you need to know how to derive the liquid in pressure. In A level, we need to learn how to derive, okay? Then upthrust, okay, we learn about upthrust. So this is some information. So this is chapter 4. Okay, chapter 5 is about work, energy, and power. Work done. Work done is we know that they must be in same directions. So when in A level they give inclined plane, again we need to resolve it until force and the distance is actually in the same direction. Okay. Then we learn about work done by expanding the gas. Then we learn about how to conserve the energy. Then all this formula actually we learned before, but we will go in deeper. The past year question will be challenging. Okay. Then at here, we need to know how to do some derivations so that we get power is equals to force times the velocity. Okay, so you will find out that actually in A level, okay, year 12, there is a lot of things now they want you to prove. Last time when we study is teacher tell you, okay, how you do calculation for power. Power is equals to F times V is the force times velocity. That's all. We don't tell you that how we derive to get this. You don't need to really know. But in A level, you have to know. Okay, for example, how we get mgh for the GPE, how we get the kinetic energy formula, all these you have to know how to derive by yourself. Okay, so next, okay, it's fine. This one is about chapter 5. Chapter 6 is about deformations of solid. Okay, so we will learn about when the spring is combined, so how we know the total spring constant. Okay, then we will differentiate out elastic limit and limit of proportionality is different thing. If you are in year 10, we learn only limit of proportionality. Okay, if form 4 we learn about form 5 we learn about elastic limit, but we never talk them together. So most of the time in all level we'll think that elastic limit and limit of proportionality actually is the same point, but no, in A level year 12 they are different. Okay, so we'll learn about this. Then there's new things, it's called Young modulus, so you need to do some calculations to find out the Young modulus for the spring material. Okay, so what else? Okay, elastic and plastic behavior. Okay, then how to calculate the strain energy, or we say elastic potential energy. And this is the graph for the rubber band. And then this one is for the wire. So what is the meaning for each area? Then we will know. This is about chapter 6. Okay, deformations of solid. Then chapter 7, we will learn about wave. Uh, Previously we learned type of wave. We learned transverse wave and longitudinal wave. That's all. But in year 12, we are not only learn about transverse and longitudinal wave, but we are classify it into progressive wave, and this one called stationary wave. Okay, chapter 7, this is chapter 8. Chapter 8, we learn about stationary wave. Chapter 7, here we learn about progressive wave. So progressive is the wave that they will travel, move forward. Okay, then it at here, chapter 7, we'll learn what is the phase difference between the two waves. Okay, how many degree? Then after that, we'll learn how to take the reading from the CRO, how we know the period frequency, how we calculate the speed, amplitude, and so on. Then here we learn about intensity, formula for it. Then we do some calculations. Transverse and longitudinal wave, okay. Both of them can be progressive wave. Okay, both of them can be a progressive wave. So we'll find out after like how many seconds, how was the pattern of your wave, something like that. We will learn about this. Then we learn about Doppler effect. This one is a new thing. No matter you are from 4, from 5, or year 10, year 11, this is a new thing for you. Okay, then this is about wave in chapter 7. Okay, then chapter 8, or the chapter 7, one more here is called electromagnetic spectrum, EM wave. When we study about wave in year 10, we never asking you to memorize. No need to memorize. But you need to know the characteristic. For example, the radio wave actually is the longest wavelength. Gamma is the shortest wavelength, but gamma is the highest frequency. You just need to know the characteristic. But in year 12, you have to know their range of the wavelength. So you need to know actually 10 power of negative 2. This one should be the microwave. You have to know, okay? So this one we will teach you how to memorize. And you have to know what is the frequency range. And then here especially you have to know the visible light, the wavelength of visible light. All this we have to know, okay? Then one more new things for you is polarizations. So here, Yeah, this is the new thing. We'll learn about this in this is chapter 7, okay? Superposition is chapter 8. It's also wave. Just now is progressive wave. Now is stationary wave. The wave doesn't move forward, okay? It just move up, down at the position, okay? So we'll learn how it works, okay? Then what is the difference between stationary wave and progressive wave, okay? Then we will learn how to producing three keys to producing the stationary wave lah, okay? Then after that, we learn about diffractions, interference, something new inside. In form 5, we learn about this. But if you are graduate from IGCSE, this is new thing for you. We never learn about this, okay? Then diffraction grating is new thing for both of us, okay? No matter you are from SPM or from IGCSE. Okay, this is chapter 9. Okay, chapter 9 is about electricity. So you need to know that derivation again. Okay, so this is the new formula for us to do calculations, more deeper knowledge. Okay, then potential difference, power, energy. After that, you need to know about VI graph, okay, related with the resistance, then resistivity and so on, okay, involved with the sensor LDR and thermistor. This is chapter 9. Okay, chapter 10 is called DC circuit. This chapter, for me, I observe my students, this is the challenging chapter for them lah. Okay, so this chapter is quite difficult. Okay, the question is challenging. So, okay, this is about, we will learn about Kirchhoff law, first law, second law, potential divider, how you find the unknowns battery. I want to know the battery, how many volt. So we can using this circuit, how we adjust. At the end, we get the value of this unknown EMF lah. Okay. Then last chapter is talk about particle physics. So we got total 11 chapter in our year 12. So this is the last chapter. For me is this chapter is easy, but some part we need to do some memorizing. For example, okay, the front part still fine. Okay, we just add in the beta negative, beta positive. Okay, beta negative is actually electron. Positive we call it as positron. Actually, it's same magnitude as the electron, but it's in uh opposite sign. Okay, so here the things that you have to memorize, not that difficult, but have to memorize is this part lah. Okay, we learn about fundamental particle in the last chapter. We learn about quarks. Okay, so what is the 6 quark and what is their magnitude? You have to memorize. Then how we classify them, okay, in hadron, then lepton, then hadron, then we classify into another 2 group again, okay, like this. Then after that, how come the proton, we say proton is a positive charge, so we never think about how we get this positive charge, but in year 12 we need to prove it. Okay, so proton is actually consists of up down quarks. So up quarks is this, then my plus the down quarks. Down quark is negative 1/3 E. So at the end we prove it, mathematics plus together, at the end we know that positive E. Then we know that a neutron is no charge. How we know? Year 12 we have to prove. So we prove. At the end it's 0 E. This is what we have to know. Not that difficult, but you have to memorize for this part, okay? Then what else? Beta decay. Beta we got 2, negative, beta negative, and beta positive lah. Okay. So overallly, this is the total 11 chapter that we have to learn in our year 12. Some of them in my mind map, you might be feel that easy. I learned it before, but actually no. When we goes to the past year questions, it will be very, very challenging for us. We are just learning, then we need spend time to do a lot of practice on our past year question. Okay, so okay, we will start our lesson today. This is the lesson number 1, which is the physical quantity. Okay, so here physical quantity is the quantity that can be measured. Okay, can be measured meaning that mass can be measured, okay? Mass can be measured. For example, this one is 80 kg. We can measure and we get 80 kg. So mass is a physical quantity. Time, okay, let's say 10 seconds. So this is a physical, time is a physical quantity. Temperature 37 degrees Celsius. Okay, so at here, any other example? There's a lot of example. For example, volume can be measured. Okay, area can be measured. Length of your table, you can measure 1 meter. Okay, speed, you can measure how fast the speed. Okay, 10 meter per second. So can you find out that the 80 kg 10 second 37 degrees Celsius actually they consist of what? They consist of magnitude. This is called magnitude. Magnitude and unit. Okay, so a physical quantity is they have a magnitude and unit. Okay, so at here, length is 100. 100 is magnitude, m is the unit. So I can say that length is a physical quantity. Okay, we look at the example number 1. This is 2023. Okay, what represent a physical quantity? First one, A. This is a magnitude only. Magnitude only. So it doesn't have any unit. Okay, so this is magnitude. No, this is unit. This is magnitude plus unit. So answer should be C. C is a physical quantity. Okay, it represent a physical quantity. 7.0 Newton is actually a force. Okay, so Newton is force, unit for force. So force is a physical quantity. Okay, 40% not cannot represent a physical quantity. Okay, so this one is just introduction, and we know about this one, right? Okay, if no question, then we will go to your page number 2. Okay, because this is the first lessons, so I need to let you know that rate goes in next on page. Okay, you to have some times to complete some exercise. Then after that, everyone you give me some reaction. So I know that most of you actually already finished and we can do some discussion. Then you press the reaction button. Okay, so page number 1 should be no problems, right? Can we go to the page number 2? If yes, yes, thank you. You press the reaction button so I know that we can proceed. Okay, so thank you. Okay, estimation. So page number 2, estimation is something new for us. Okay, we need to know how we do some estimation. It's very important in our life. Okay, so we want to know that whether the value that we do calculation, is it correct or acceptable, or actually it's obviously wrong. Okay, so you can do some estimation. For example, in your exam, maybe in your exam, you estimate, hey teacher, I think that I will get 90 mark. But at the end, the result come out is 50 marks. So your estimation is very wrong lah. Okay. But estimation is helping you to estimate, how many A I able to score in my exam. Something like that. Estimation. So estimation is a new part in our A level lah. Okay. So here, mass of the adult, we do some estimations. So for the adult person is roughly like 60 to 80 kg lah. Okay. So maybe we can write 70 kg. Okay. Apple. Do you know that? What is the mass of the apple? We never think about that, right? Okay. Now, you can go to a supermarket and roughly observe. So starting from today, you have to observe whatever the length, the height, the mass of the object surrounding you. Okay. For the mass of the apple is roughly like 100 gram to 200 gram. Okay. So maybe we write 200 gram. You don't tell me that apple is 1 kg. Your estimation apple is 1 kg. Okay. Okay, family car is roughly like 1,500 kg. Lorry at here is roughly like 10,000 kg to 20,000 kg lah. Okay, so at here I can helping you to do some memorizing is person is 10 power of 2. Okay, so 10 power of 2, where 10 power of 2 is okay. 60 to 80, then this one is 10 power of 3. Then this one is 10 power of roughly 10 power of 4. Okay, for the lorry. These two, car and lorry, they come out few times in the exam. They're asking you to estimate maybe the speed of the car or momentum of the lorry, something like that. So you need to roughly know what is the mass. Then you only can do some estimation. What? Okay, the coin is 2 gram, raindrop, hydrogen atom. For me, this one is a very popular lah. You have to know. Okay, one more is 1 ton. It's actually 1,000 kg. Okay. Then radius. Radius for the Earth is 6,400 km. Football is 10.0 cm. Okay, let's say you know you like to play football. You roughly can know that how many cm of the football. Then you think tennis ball is bigger or smaller than the football. So you think about that. Oh, smaller, much more smaller. Okay, half. Then you do some estimation. If you think that roughly half, then 5 cm. Okay, then golf ball even smaller than the tennis, then you guess on maybe 2 cm or 3 cm. Okay, then atom, this one you have to know. Okay, pass your question, you have to roughly know it's -10. Okay, it's very very small. Density of water, this one we know what, right? 1,000 kg per meter cube. Okay, one more thing that I want to tell you. In year 10 or year 11, we will roughly write 1,000 kg per meter cube. This is the ways that we write when we're sitting for our IGCSE. But right now, we goes to A level. We will change the way we write. Okay, we'll change to become kg meter power of -3. Okay, or 1 gram per cm cube. Okay, all these they assume we know already. Speed of sound in the air. How fast the speed of sound in the air? Okay, it's 330 until 340, something like that. Okay, so we can write 330 ms -1. In the water is roughly 1,500 ms -1. Sound speed in the solid is 3,000 ms -1 to 5,000. It depends on the material lah. Okay, this one we already know in year 10. Okay, year 10 we already learned about this. We know already. Light of the speed of the light in vacuum is 3 times 10 power of 8 ms -1. Okay. Olympic runner, this one important, you have to know. Okay, Olympic runner, how fast the speed? How we know? Okay, you can think 100 meter. Normally, normal person, how many seconds you need to complete the 100 meter distance? Okay, maybe like 13, 14, 15 seconds. But for Olympic runner, they can complete in 10 seconds. If not mistaken, the latest record, it should be less than 10 seconds. Less than 10 seconds. Okay, by the way, so at here, 1 second, how, well, 1 second, yes, 1 second meaning that 10 meter. So basically, how fast the Olympic runner is 10 meter per second. Every 1 second, it can run 10 meter. Okay. So for your walking speed is roughly 1 meter per second. Okay, I want to add car speed. How about car speed? Okay, I think you guys already got license. You can drive, right? So in Malaysia highway, we always say that, hey, you cannot. The speed limit is 110 kilometer per hour. Am I right? So if I convert to meter per second, it will be 110, then times 10 power of 3 divided by second is 360. 3,600 second meter. So at the end, you will get the answer, if not mistaken, is 30 meter per second. Is it correct? Let me check. 11110 times 10 power of 3 divided by 3600. Okay, yes, it's roughly 30 meter per second. So car speed at here, 30 meter per second. Okay, car speed. Okay, so at here, current in the appliance. This one is, for example, kettle lah. Okay, the current that we need is 13 ampere because kettle is they need a high current to flow to heat up. Okay, then EMF of the car battery is 12 watt. Power of a light bulb roughly is 60 watt. Okay, so this one light bulb at here is talking about filament. If LED, it will be less than this value lah. Okay, all this estimation is we predict. Okay, predict and estimate. Not predict, it's called estimate. Okay, estimate the value, and then we can find out which one is the make sense answer lah. Okay, so for here goes to page number 3. Okay, here have you finished writing down? Can we proceed to the page number 3? Okay, boys and girls, here every time when you do the questions, if you get the answer, you can private message to this account Newton Scholar. So I will know. Then I will let you know that, hey, you are correct. For example, Jun Xiong, your answer is correct. Jun Xiong, your answer is wrong. Think again. Maybe which part, I can guide you. Okay. So for the question number 1, any of you can choose a correct answer. Can you let me know your answer by you type your answer in the chat box? You choose the Newton Scholar. The Dr. Low is my iPad. So I will check using the account of Newton Scholar. Any of you? Let me check. Correct, Jun Xiong. Shanice, correct. Yes, very good. Okay. Sink in water. That means that it's related with water. So you have to know density of water. Chang Yu, yes. Second answer is correct. Chang Yu, second answer is correct. Okay, sink. That means what? Denser. Am I right? Denser. Denser means that the stone density must be higher than the density of water. Am I right? Yes. Then, do you know the density of water? That is the problem. Okay. So we know that is 1000 kg per meter cube. That means that your answer must be greater than this. Okay. So at here, which answer is correct? This one, X20 is 800 only. Then this one is 2000. Okay. So the here kg per meter cube, kg per meter cube. Okay, C and D, we straightly make it wrong. It's because the unit is not in kg per meter cube. It's wrong unit. So this C and D confirm is wrong. So from answer A and B, we know that answer should be B. Okay, so this is the estimation. Okay, estimate is greater than 1000. So maybe it's 2000, maybe it's 3000, maybe it's 1500. Yes. Okay, that is a possible value for the density of stone. Okay, so we go to second question. Second question. What is a reasonable estimate of the volume of an adult person? Wow. Have you ever think that what is the volume of you? Okay, so how for us to solve this kind of question, how we do the estimation? Okay, my suggestion is we can think a model, maybe it's a cylindrical like this. Okay, of course, we are not this shape lah, but estimate what? Estimate doesn't matter. Okay, now ask yourself, what is the estimate height? You can average adult height. So what is this hash? Okay, then ask yourself roughly from your shoulder to another shoulder here, what is the diameter? Okay, what is the diameter from here to here? Okay, volume is area times the height, right? So here, this is a circle surface. So at here is pi r squared times your height. Now, you need to do estimation about yourself. Try to estimate from here, shoulder, the length of the shoulder. How many meter? Okay, how many meter? Then, this is diameter. Then you need to divide it by 2 lah. Okay? Radius is diameter divided by 2. Okay, can you try? I guide you until here. Can you try? And then see whether you're able to get the correct answer or not for question number 2. If you're able to get the answer, then you type your answer here. So I know that you complete, and I know that most of you able to get the answer, so we can proceed to the next question. At the same time, take the attendance. Wait me for a short while. Vision, no. Try again. Maybe certain value is too big or too small. You try again. Junxiong, yes. Junxiong, yes. Shanice, yes. Any others you want to try and then tell us the answer? Okay, I estimate lah. Okay, I'm a girl, so estimate. Changyu, yes, correct. Answer correct. Okay, I'm a normal girl. Normally the height for a girl is 1.6 meter lah. Okay, so we test. We estimate, not test. Estimate. Okay, what is the length for the shoulder here? So it's roughly like 40 cm. So 40 cm is 0.4 meters, roughly only, okay? So pi, this one 0.4 divided by 2 square times the height 1.6 meter. Okay, so at here, if I press the calculator, roughly I will get 0.2 meter cube. 0.2 meter cube. So which answer is the best estimation? Answer should be A. Answer should be A. Okay. So of course we are not cylindrical, right? So it will be slightly less than this value. Is a reasonable estimation. Okay. So until here, is that clear? If clear, then you can press the button sign. No. Okay. Thank you. Okay. Number 3 at here. I don't guide you for this. Number 3, can you try? What is the reasonable estimate of kinetic energy of an Olympic athlete sprinting in a 100-meter race? Okay, kinetic energy formula 1 over 2 mv squared. So you have to estimate the mass, estimate the speed in a 100-meter race. So can you try and then tell me which answer is the correct answer? Every time our tuition, we will have the recording video lah. So after we finish the tuitions, so maybe like 10:30 or before 11. If already after 11, then I will send next of the day. Okay. After that, we'll share out. So if you are absent from the lesson, or maybe you want to restudy again, actually we have the video. You can study again now. Okay, that is not a big problem. Okay, Junseong correct. Good job. Shanice correct. Vision correct. How about Changyu? How about others? Try is okay. We don't know each others. If you choose a wrong answer, also never mind, dear. Okay. Additional, yes. Then Yuan, yes, correct. So answer will be C. Okay, this one 1/2. We can estimate adult 70 kg, or maybe you want to 60, 65, doesn't matter, okay? Then the speed, just like I told you, 100 meter, they take 10 seconds, what? So that means that the speed will be 10 meter. So this one, the speed will be 10 meter per second. So it's 10 square. So your answer 3500 joule. So at here, C will be the possible answer. Okay? Okay, dear, we goes to the question number 4. Which maximum speed is not a reasonable estimate? Although some of the answer A, B, C, D, teacher, how can I know the container ship? How can I know the racing car? How can I know the snail? It's okay. You try to eliminate the wrong answer out. That is not a reasonable estimate. So you try to make them in meter per second, meter per second, meter per second, and meter per second, and ask yourself which one is not a reasonable estimation. Okay, try with question number 4. How to pronounce L? Is it Lan? Lan Yuan? Is it? I worry I pronounce your name wrongly. Or I call you Yuan. Okay, Yuan, your answer not correct. You try you try to make them all in meter per second. Then you try to using which one that you familiar. Is it possible for that speed? Try again. Shanice correct. Vision correct. Changyu correct. Yes. Dear, although I don't know about container ship is okay. We just left it. Okay. Olympic sprinter, we know what? Okay. We convert it 0.1 k times 10 power of 3 divided by 1 second. Okay. So at here, we will get 100 meter per second. So for the racing car is 9,000. C is times 10 power of negative 2 per second, per 1 second. So at the end here, I get 90 meter per second. For the snail at here, 0.01 times 10 power of 3 divided by hours. So I convert it into 3,600 seconds. This one is in meter. So my answer is 0.0027 meter per second. Okay, from here, A, B, C, D, which one is not a make sense estimation? So we don't know container, we don't know racing car, we don't know the snail. It's okay. We know about the Olympic sprinter one, right? Okay, Yuan, answer correct. Okay, dear, here. You see, Olympic sprinter. Just now we said that it's run 10 seconds in 100 meter, right? So the speed should be 10 meter per second. This one is already very fast. So how come you can go to 100 meter per second? This is very, very wrong estimations. Can you see that? Even is faster than the racing car. Is it possible? Not possible, what? Right? Right. Okay. Then 90 meter per second, is it make sense for the racing car? Yes, it's possible. Why? Just now here we got do some calculation for the car speed, normal car speed, and also we being limited by the highway government, right? It's 110 kilometer per hour. Then we change to 30 meter per second. So for the normal car speed is roughly 30 meter per second. So that means that your racing car, of course, must be greater than that. So 30, then greater than 30, here is 90. Makes sense or not? Still makes sense. Still a reasonable estimation. But for the B, Olympic sprinter is no 100 meter per second. You got install whatever motor behind you. Okay, so answer at here should be B. This is a wrong estimation. Okay, not a possible answer. Okay, can we go to your page number 4? Yes, thank you. Okay, let's go at here. Unit, SI unit. Okay, here. Uh, we learn about base quantity. Basically, there is 7 base quantity, but in our year 12, we only need to know about this 5, which is the mass. Unit is in kg. Then the symbol for the mass unit is kg here. Length is in meter, time is in second, temperature is in Kelvin, capital letter K, current is in ampere, capital letter A. Okay, another two is in A2, okay, year 13. So you need to memorize it. It's very important. We know that this 5 base quantity. Okay, I'll teach you how to memorize this 5 quantity. During the MCO, we always need to weigh what before you go out. Okay, along all the times you are outside, you need to weigh the mass. Am I right? Mass. Okay, how many kg? Count in kg. We weigh kg. Let's say 1 kg. Okay, kg is the unit for mass. 1 meter is the unit for length, or we say distance. Length. 1 ampere. Ampere is the unit for current. 1 second. Second is the unit for time. 1 Kelvin. Kelvin is the unit for temperature. So dear, finish. Finish story. 1 kg mass. So 5 base quantity already in our brain. Settle. Okay, this one is very important. You have to know this 5 base quantity. Okay, until here, is that clear? Okay, Junxiong, okay. Changyu, okay. Okay, dear, we try with the past year question. This is 2023 past year question. Which quantity is an SI base quantity? Which one is base quantity? 1 kg mass, right? 1 kg mass. So at here, false, no. False is not a base quantity. It's a derived quantity, okay? Yuan correct. Yuan correct. Wait, this is quantity, base quantity, not unit. Force is F equals to ma. It's a derived quantity. It's not a base quantity. Newton is a unit, not a base quantity. It's the unit for base quantity. Changyu correct. Changyu, wait. No, Changyu not correct. Second is a unit also. Second is a unit also. Yuan correct. Okay. Additional. Additional is a doctor. Doctor title. Is it same as me? Okay, here Newton and the second is actually the unit. So base quantity is actually the time. Base quantity is here, dear. Here. This is base quantity. This is the unit for base quantity. Then I using the unit helping us to memorize this 5 base quantity. So it's not unit. Don't choose unit. This is the technique for me to memorize. Okay, memorize the base quantity. Okay, dear, here. What is the symbol for the SI base unit? Now it's talking about unit of temperature. So temperature unit is in Kelvin. This one easy. Kelvin. Okay. Which unit is not an SI base unit? 1 kg of mass, right? 1 kg, this one, yes. Mass, M, A, S. So C is wrong. C is actually the unit for no. No such unit. C, got C or not? Q equals to column. Yes, column. Coulomb. It's a unit for charge. Okay, unit for charge. It's not a base unit. Okay, so answer is C. Okay, can we proceed to the page number 5? Okay. Okay, thank you. So it goes to page number 5. Derived unit. Derived unit actually they will be consist in how we say in terms of base unit. So for example, speed is actually distance divided by time. Actually, it's a length divided by time. Can you see that length and time actually is base unit? Okay, so derived unit consists of some combination of base unit. It can be multiplied or divided. Okay, so we in our year 12 we need to derive the SI base unit. Okay, SI base unit. That means that all the unit that appears, the unit is only at here. kg, ms, ka. No others, no Newton, no column. Okay, no ohm. Okay, all in this, in terms of this. Okay, first at here. Velocity is displacement divided by time. Displacement is length. So at here, it should be the meter. Meter is the unit for displacement, or we say length. Time is in second, the unit in second. So at here, SI base unit for velocity, ms negative 1. So can you see that kg, meter, as 1 kg of mass. So m and s, this one, m and s. So we will having all these, we'll try to learn how we derive in terms of this base unit. Okay. So second one, of course, we know that acceleration, teacher, I know acceleration is ms negative 2. I know, we know, okay? But later when we go further, then it will become very complicated. So we're starting from the easier one, okay? Acceleration is velocity divided by time. So just now this velocity here, this is the velocity base unit. So we continue. So it's ms negative 1 divided by time s. So I get ms negative 2 in terms of this kg mass. Okay? Force. We know that force is in Newton. Then how it is in SI base unit? Okay, we know that force is F equals to ma is in kg times acceleration ms negative 2. So we get kg ms negative 2. Okay, momentum, mass kg, velocity ms negative 1. So in kg ms negative 1. This is momentum, unit for momentum. Can you see that all the final unit is come from this 5 kg mask. They are combination. No others unit like Newton. No. Okay. Power. Power is force divided by area. We'll say, teacher, pressure unit is Pascal, but at here is SI base unit. So we cannot write Pascal. Then teacher, Newton per meter square. No, no Newton. Newton is not a base unit. So at here, what is your force? So just now we learned about force is this. kg m s negative 2. So we put at here. kg ms negative 2 divided by area meter square. Length times length. So it's meter square. So at here it will become kg m negative 1 s negative 2. Can you see that? kg, m, and s come from these 5 base unit. Is that clear until here? Is that clear? Yes or no, dear? Okay, then work. Can you try? Can you try your work? What is the SI base unit? You try. 5 seconds, 10 seconds, 10 seconds. Okay, 10 seconds. Try it right now before I tell you the answer. Force. In terms of base unit, kg ms negative 2 times distance is in meter. So it should be kg m square s negative 2. Do you get the same answer as me? kg meter square, then S negative 2. Okay. If okay, you're able to prove it and get the same answer, you give me some reaction. Press the button, then I know I can proceed. Okay, thank you. Thank you, dear. Okay, power is work divided by time. Work is actually energy. Energy is actually work. Okay, one thing, you look at this, teacher. Work is Fs, right? If I say what is energy? Energy is what? Can I say that energy 1 of over 2 mv squared? Also, can I get kg meter square s negative 2? What do you think? Okay, this one is formula for the work. Then it will be same as the energy because work done is energy transfer. So by right, if I using energy, should I get the same answer or not? My answer is yes, you should get the same answer. So you look at here, mass is in kg. Then the speed at here, what is the unit for speed? The speed is in meter per second. Then this one got square, so I need to square it. So at the end, I will get m square s negative. So can you see that? I will still getting the same SI base unit. Is that clear? Not only must use work to find the unit, we can also using energy 1 over 2 mv square, or even we using mgh to derive the unit. We also at the end get the same SI base unit. Is that clear for this part? Okay, thank you. So can you do calculation for the power? You do calculation for the power. This one I erase first. Okay, power is the work divided by time. So it's kg m square s negative 2 divided by time is in second. So I will get kg m square s negative 3 for power. Okay. Yuan kg m square s negative 3. Very good. Okay, voltage. Voltage is the power divided by current. So can you continue? Voltage, what is the SI base unit for voltage? Power, so kg m square s negative 3 divided by current. Unit for current, ampere. Okay, dear, do you able to get the same SI base unit as me for the voltage part? kg m square s negative 3 a negative 1. So can you see that 1 kg of mass MAS kg? All is in our base unit, 5 base unit. Okay? Is it okay for voltage? Okay, then we continue with resistance. Try with the resistance, voltage divided by current. Coco, do you able to follow? Shanice, Ting Wei, Wei Shen, Yen Yi, Victoria. Okay, good job. No need to be shy, because we don't know each other's. You can private message me, okay? My dear, here. Resistance, voltage. Voltage is kg m square s negative 3 a negative 1 divided by current, ampere. So kg m square s negative 3 a negative 2. Okay, step by step. Okay, if you already have the ideal, then we are going to go to the past year question and try. Now, the past year question, I do not want you to refer back to this page. Do not refer back to this page. Okay, using the technique that I teach you. So, is it okay for us to proceed to the page number 6? Okay, so I turn to page number 6. Okay, if I'm too fast, let me know. Okay, dear. Okay, what is the ohm expressed in SI base unit? Okay, dear, ohm. Ohm is a unit for what? Unit for resistance. Am I right? R. What is the formula for R? R is equals to V over I. Am I right? Then you have to think, what is the SI base unit in